Lesson 14. Arduino Session Digital or Analog Input. Contents. The topics covered in this lesson are analog and digital signal, pull-up and pull-down resistance, reading a pushbutton, joystick. The tasks or activities for this lesson include buttons, joystick, analog and digital signal. Analog signals are continuous signals that vary in amplitude and frequency characteristics over a time period. Analog signals are represented by a sine wave. An example is a human voice. Digital signals are in the form of pulses represented in binary form. Unlike analog signals, digital signals have a finite range of 0 to 1. An example is the transmission of signals in a computer. Analog and digital signal. Why do we need analog to digital converters? In the real world, most data is characterized by analog signals. In order to manipulate the data using a microprocessor, we need to convert the analog signals to digital signals, so that the microprocessor will be able to read, understand and manipulate the data. A2D. A device that converts analog signals into digital signals, which enables the computer to process the information. D2A. A device that converts a computer-processed digital signal into the required analog signal. On Arduino boards, analog pin labels, A0, A5, are prefixed with an A to indicate that these pins can read analog voltages. The Arduino's ADC is a 10-bit ADC, capable of detecting 1024 discrete analog levels, which is 2 power 10. This means converting an input voltage from 0 to the operating voltage, 5V or 3.3 volts, into an integer value from 0 to 1023. For example, the Arduino Uno provides a resolution between 5 volts 1024 units or 4.9 millivolts per unit reading. Analog and digital inputs in Arduino. Arduino is capable of reading both digital and analog signals through its dedicated pins. To read digital signals, the digital read function is used, which reads either 1 or 0. To read analog signals, the analog read function is used, which reads integers from 0 to 1023. Analog and digital outputs in Arduino. To write digital signals, the digital write function is used, which writes either 1 or 0. To write analog signals, the analog write function is used, which writes integers from 0 to 255. Map analog input to analog outputs. Components needed to run this program are Arduino Uno, potentiometer, jumper wires, LED, 220 ohms resistor, and a breadboard. Here, the analog values of voltage received from 0 to 1023 are mapped to outputs of 0 to 255 by turning the potentiometer knob. You can also observe in the video that the LED brightness is increasing as the potentiometer knob is turned from 0 to high resistance. Pull-up and pull-down resistance. A pin can be in one of three states. It can be low, that is, a voltage close to 0 volts, or less than half the voltage supplied to the chip's power supply, is injected into the pin. A pin can be high. This means that more than half the voltage supplied to the chip's power supply is applied to the pin. Alternatively, the pins can be floating. That is, the pin is not connected to a low or high voltage. In this case, the pin can randomly toggle between low or high. Pins can float because they do not have a well-defined voltage signal input. Things like external noise can arbitrarily take both values. You don't want the pin to float. So, you usually want to put a defined signal on a pin so that its state is known exactly. That way you know for sure if it's low or high. That's exactly why we use pull-up and pull-down resistors. Pull-up resistors are used in electronic logic circuits to ensure that inputs to the Arduino settle at expected logic levels, if external devices are disconnected or high impedance. If a pin configured as input with pin mode function is not given a definite state, left floating, then it will experience random changes in pin state, and pick up electrical noises. Pull-up and pull-down resistance. To prevent the floating condition, a pull-up, or pull-down, resistor connects the pin to 5 volts, or GND. Just because you have nothing at all connected to an input pin doesn't mean it is a logical 0. Pull-up resistance. The resistor makes the input state high when the button is not pressed. When the button is pressed, the Arduino pin takes the least possible path and connects to the ground and reads as low. Reading a push button. Push buttons are found on remotes, ACs, washing machines, etc. The push buttons have a built-in spring mechanism. This mechanism allows the button to return to its original state when you stop pressing it. The state in which the button is not pressed is the open state, and the state in which the button is pressed is the closed state. A push button has 4 pins in which 2 of each side are connected internally and gets in contact when pressed. In the image on the top right corner, pins 1 and 3 are wired together and pins 2 and 4 are wired together. When the button is pressed, the blue and red lines establish a connection. In a closed switch, electricity can flow through the circuit. In an open switch, electricity cannot flow through the circuit. Activity 1. Is the circuit shown in the picture a pull-up or a pull-down circuit? Activity 1 solution. It is a pull-down circuit, as the resistor is connected to the ground. Activity 2. Create a pull-up circuit using these components and write a program to turn on the internal LED on P13 when the button is pressed. Components required for this activity are Arduino Uno, button, 10 kΩ resistor, jumper wires, and breadboard. Activity 2 solution. The circuit for the pull-up circuit with an input connected to pin 2 of Arduino is as shown. Code to read a pushbutton. Components required: Arduino Uno, pushbutton, 10 kΩ resistor, and wires. For a pull-up circuit, when the button is pressed, the button value is read as low, hence in this case, the LED turns on. But for a pull-down circuit, when the button is pressed, the button value is read as high, and in this case, the LED turns off. Debouncing in a pushbutton. When you press a pushbutton, 2 metal pieces touch and short the power supply. But instead of connecting immediately, the metal part connects and disconnects repeatedly before an actual stable connection is established. The same is true when releasing the button. This results in false triggers or multiple triggers, such as multiple button presses in a very short time, fooling the program. To avoid this issue, debouncing must be implemented. This can be done in software by adding delays or using debouncing hardware circuits. Code to debounce a pushbutton. This slide shows the code to avoid bouncing in the button by just adding a delay of 100 milliseconds as shown. The video shows the internal LED being illuminated as the button is pressed. Joystick. A joystick is an input device that can be used with Arduino as a gaming console. The joystick consists of 2 mechanically linked potentiometers arranged to capture the horizontal and vertical components of the joystick. Therefore, the resistance of the potentiometer changes independently depending on the joystick position. There is usually a push button that activates when you press the joystick. Joysticks can be used in gaming, robot control, RC cars, drones, etc. Joystick modules typically provide an analog output, and the output voltage provided by this module changes constantly depending on the direction of movement. By interpreting these voltage changes with the Arduino, the direction of movement can be determined. Activity 3. Read X and Y values from the joystick. This slide shows the connections of a joystick to Arduino. Activity 3 solution. This slide shows the code and working video of a joystick. As the button is pressed, the switch value changes from 1 to 0. As the joystick is moved on the X-axis, the values change from 0 to 1023 from the home position. Similarly for Y-axis, the values change from 0 to 1023 when the joystick is moved in the Y direction. Activity 4. Task 1. Use all the sensors taught in the lecture. Task 2. Sense the digital input from the push-button switch and turn on/off the LED using the switch, using pull-up and pull-down circuit. Task 3. Using the joystick, move the arm up and down, and when you press the joystick, the arm should open. Task 4. Use a potentiometer and change the brightness of the LED. Task 5. Intermediate level. Use a color sensor and show the color shown to it on the serial monitor. Task 6. Advanced level. build a counter using a pushbutton and show the output on the serial monitor. The concept to be used is debouncing. Thank you.